Hey kiddos, today we're going to be talking about perimeter and area. So let's start with what is perimeter. Perimeter is essentially being able to add the lengths of all sides of any polygon. So for example here, if I have this polygon here and we add up all of its sides, which are 5, 3, 2, 1, 2, 4, and 8, we would end up with a perimeter of 25 units. Area is the number of square units enclosed by a polygon. So notice here, if you pretty much just count all our little squares, we end up here with an area of 4 times 4, 16 centimeters squared would be the area for this square. Alright, so looking at a few area postulates. First one is that the area of a square is the square of the length of a side. So basically, it is the side squared. Yes, you can use base times height for a square, but more appropriately, you will see that the area of a square is the side squared. Number 2, if two figures are in fact congruent, then that would mean that their areas are also congruent. And 3, the area of a region is the sum of the areas of its non-overlapping parts. So notice we do have this funky looking polygon. And notice if I create these horizontal lines here, okay, I create 3 shapes that are actually very familiar to me, and that is rectangles. So I have 3 different rectangles. So essentially, if I take the areas of those 3 individual rectangles because they're not overlapping and I add them, then I get the total area of this polygon. So 6 times 3 gave me this area to be 18. Then the middle rectangle, 8 times, well, let's see here, how do we get 8? We see that's 3, that's 6, that whole thing is 8, so therefore that piece is 2. That whole thing is 6, this little section here is 2, so therefore that has to be 4. So 4 times 2 gave me the middle rectangle, which is 8. And then finally the last one again, 6 times 3 gives me the 18. So when I take these values and I add them, 18 plus 8 plus 18, I get a total area of 44 units squared for this particular polygon. So let's talk about first the area of a parallelogram. So we hopefully recall a lot of important information about parallelograms, but to find the area of a parallelogram, it's very similar to that of a rectangle. So the area of a parallelogram is basically the product of the base times its height. So it's base times height. Notice this is where the height is bounded. It is not the diagonal. Okay, so it is not a diagonal. The height is an altitude that can be drawn. Notice it does create a 90 degree, so we do end up with a right triangle here, okay? So remember that because you may have to rely on Pythagorean theorem at some point to help you determine a piece of the base or a piece of a height, all right? So let's look at our first example. Now, we know that the area is base times height. And the first part that we're going to answer is the perimeter. And hopefully we do recall something unique about the perimeter of a parallelogram. And that's that opposite sides are congruent. So therefore, if this is 7, then we know that this is also 7. And if this is 12, then we know that the top is also 12. So the perimeter would be to simply just add up those 4 sides, and you end up with 38 inches as the perimeter of that parallelogram. Now let's look at the area. Area is base times height, base, height. So to find the area, we're going to be basically doing 5 times 12, which gives us an area of 60 inches squared. Moving on to the next picture. Now notice for this one, we have drawn the height outside of the parallelogram, and that's totally okay because essentially if I were to draw this, these two sides would end up being congruent. So don't freak out just because it's on the outside of the parallelogram. Okay, that is totally acceptable. Or if that doesn't feel right, then you can always redraw it on the inside. Okay, so first let's find the perimeter. So therefore, if we know that this side is 4, then this side is also 4. If the bottom is 5, then the top is 5. So when I add that up, we get 18 yards as the perimeter. Now for the area, which we know is base times height, always get in the habit of writing the formula down. And we can see here that the base here is 5 and the height of this parallelogram is 3. So you get 5 times 3, and that will give us an area of 15 yards squared. All right, so let's talk about the area of a triangle. Now, the area formula for a triangle is simply base times height divided by 2. Making sure again here that you see that this altitude or this height is drawn in, okay, which creates that 90-degree here as well. So this is our base. That would describe our height. So notice none of these diagonals represent a height, all right, for a triangle. And let's go ahead and try a few examples. All right, so first things first, let us find the perimeter for this triangle, which I'm going to underline all the numbers that represent the perimeter, which would be 10, 17, the 15, and the 6. So when I add up all those values, we get a grand total of 48 inches would be the perimeter of this triangle. Now to find the area, we know the formula is base times height divided by 2. I'm going to circle the base. Well, in order to get the base here, I actually have to add 15 plus 6. So I get the base to be 21. Now notice the height I don't have, but I do have two right triangles here. So I can use one of them to figure out what the height is. That's basically relying on Pythagorean theorem there. So I'm going to use the smaller one. So when I work this out, we would have 10 squared minus 6 squared equals a squared. So notice I'm kind of already reversing the traditional Pythagorean theorem since we're given the hypotenuse. Hopefully you guys see that. If not, just work it out using a squared plus b squared equals c squared. Anywho, so when I do that, that's 100 minus 36 equals a squared. 100 minus 36 leaves me with 64 equals a squared. And then when I take the square root of that 64, we get a to be 8. So the height is 8. So now when I plug into the formula, we get base, which is 21, times the height, which is 8, and then we'll divide that by 2. So 21 times 8 is 168, and then divide that by 2 leaves us with an area of 84 inches squared. All right, moving on to the next example. First things first, let's find the perimeter. I'm going to underline all those numbers that I need for the perimeter, and that is the 41, the 26, and the 33. So when I add those three values together, we get 100 units as the perimeter. Now for the area. Area is base times height divided by 2. So the base here is that 33, and we can see that the height is drawn here on the outside, and that's completely fine for this triangle. Okay, it's marked as 17 here. So we would have a base of 33 times the height of 17, then I divide that by 2. So 33 times 17 is 561. Divide that by 2, 280.5 units squared would be our result for the area of that triangle. Now let's look at the area of a rhombus. So our rhombus has a unique area formula, and that is that you would take the first diagonal and multiply it by the second diagonal, and then you would divide that by 2. Few reminders about the diagonals of a rhombus. Whoops. is that the diagonals are perpendicular, so that means they create right triangles inside of here, okay? And the diagonals bisect each other. So meaning that this section would be equal to that section, and then this piece would be equal to that piece, okay? That's one of the properties of our rhombus that we talked about in the previous unit. So we're going to have to use that information to help us answer the question of finding the area here. So let's find the area first. Notice I'm going to make my markings here, so it helps guide me here. So that's going to be diagonal 1, and that'll be diagonal 2. So looking at diagonal 1, I see that one portion of it is 6, so therefore that's also 6. And then diagonal 2, I got one portion is 8, so that's 8. So diagonal 1, diagonal 2. So diagonal 1 is 12, and diagonal 2 is 16. So according to the area formula for a rhombus, we would take diagonal 1 times diagonal 2 and then divide it by 2, which means we have 12 times, not 12 again, 16 divided by 2. So 12 times 16 is 192, and if I divide that answer by 2, we end up with an area of 96 inches squared. Now, to find the perimeter, okay, we need to know what the sides are. Now, hopefully you recall the nice thing about a rhombus is that all of the sides are congruent. So once I find one, I know all, which makes it easier for me to figure out what the perimeter is. Now, remember, the diagonals bisect each other and they're perpendicular, so therefore I have a right triangle here. So that means I can use Pythagorean theorem to figure out what this side is. So we're looking for our c value because that's the hypotenuse. So we're going to have 8 squared plus 6 squared equals c squared. So that's 64 plus 36 equals c squared. And that is 100. So 100, sorry, I know it's a little crammed here. And then when I take the square root of that, we are left with the answer of 10. So we know that this has to be 10, which means all of the sides of this rhombus are 10. So the perimeter then would be 10 times 4, which means the perimeter is 40 inches. Moving on to the next one. Same concept. Let's find our area. So let me first make my markings for my diagonals. All right. So we know that's 4, so therefore this is 4, and that's our first diagonal. So we know diagonal 1 is 4 plus 4, which is 8. Now we need to find diagonal 2, which I'm not given any information, but luckily for us, we know one of the sides, which actually means we know that all the sides are 5. So we also know that this creates perpendicular lines, which gives us right triangles here. So if we use Pythagorean theorem, we can figure out what this value is. Now this is actually a Pythagorean triple, so I have that memorized, so I already know that this answer is going to be 3. So that's 3, which means diagonal 2's length is 6. So according to the formula, and yes, you must write the formula every single time that you do one of these problems, or I won't accept it. I know, don't be mad. Be glad. So we got 8 times 6 divided by 2. 8 times 6 gives you 48, and when you divide that by 2, you end up with 24 units squared as the area for that one. And to find the perimeter, they actually gave us the side. So 5 times 4, because all the sides are the same, just like a square, will give us a perimeter of 20 units. And to the last shape, the area of a trapezoid. All right, notice my picture here looks like an isosceles trapezoid. Okay, but anywho, to find the area of a trapezoid, all you have to do is follow this formula, which is 1/2 times height times base 1 plus base 2. So essentially what you have to do is you have to add the two bases together. then you basically are taking half of the height and then multiplying that by the addition of the bases. Okay, so very crucial that you follow the formula here so that we don't mess up. Now, again, perimeter should be a piece of cake, should be a piece of pie. Literally, it's just adding up all the outsides. Okay, so in this case, it'd be, let me underline it for you so you can see, 9 plus 8 plus 10 plus 12. So 9 plus 8 plus 10 plus 12 gives me a perimeter of 39. All right, now I need, in order to find the area, I know I need the height, which is 7. I need my base 1, which is 8, and my base 2. If I have all of that information, then we can plug this into our formula. So the formula is 1/2 of height times the addition of your two bases. So the height here was 7, base 1 is 8, base 2 is 12. So we're going to take 1/2 of 7, and then if I add 8 plus 12, gives me 20. So my calculator, I can simply just put 0.5, which is 1/2, times 7 times 20, and that results in us having an area of 70 units squared. All right, now moving on to the next one, which of course you knew it was coming, is an oh-yo problem. Now let me just give you a few helpful hints. To find the perimeter, you know that you need to add up all of the sides. Now, I can easily see that if this section here is 9, then this section here has to be 9. Now, in order to find these diagonals, you're going to have to rely on Pythagorean theorem to help you find it. Okay, so for this one, you got 3 and 6 as the legs, so you need to use those values to find this hypotenuse. And then over here on the other right triangle, you have 6 and 4 as your legs, so you have to use that to find out what this is. Okay, once you've done that, then you can use your area formula and multiply the 1/2 times the height times the addition of base 1 and base 2. Awesome sauce. Ciao.